Hi friends, welcome again in the part 2 of RGB LED by Ohm Electronics. If you not have seen my previous video, I would request to watch the video first for better understanding. I would share the link in the description below. Let's get started. Now we will connect simple 12 volt RGB LED strip. So this is the circuit diagram. Here we use the Arduino pin 6, 5 and 3, 6 for green, 5 for red and 3 for blue, and connect the Arduino pins 6, 5, 3 to the gate terminal of the MOSFETs. Here we use the MOSFET IRF Z44N, IRF Z44N, and the connected 10K resistance to the ground terminal, and this is the ground terminal and this is the positive terminal. 12 volt power supply here, and this is the output terminal. This is the green terminal, red and blue and positive terminal. Here we connect as per circuit diagram. So these are the MOSFETs IRF Z44N, and these are the 3 pins of Arduino for green, blue, red, green, blue. Pin number 6 and pin number 5 and 3, and this is the LED 12 volt LED strip for 5 meter, and this is the 12 volt terminal, positive terminal and negative terminal. We will show you 2 ways to run the RGB LED. The first way is to turn the individual LED, that is red, blue and green, on off in various combination. This gives you a total number of 7 colors. We have written a function called basic colors that steps through the 7 of these colors. We are only calling the function here, telling it to run basic colors. Here the basic colors function, we have written this display 7 colors that the RGB LED can produce. Now we upload only basic color program to our Arduino board. And done uploading. Here the new trick, putting the word constant in front of a variable, indicates that is a constant value that will never change. Pin number 6, pin number 5 and pin number 3, and this variable controls how fast the loop through the colors, that is display time is equal to 100 in millisecond. Try changing this to make the fading fast or slower. So in this section, digital write red pin low, digital write green pin low, digital write blue pin low, that is the all LED off, Similarly, here just the red LED is on, so we can write digital writes red pin high and others pin, that is green pin and blue pin, both are low. And similarly, next green just the green LED on, and here also the green pin is high, others is low. So in this way we are getting 7 colors. So now switch on the circuit. So here we are getting seven different colors, just basic colors. Only we are getting 7 basic colors. The previous function turns the individual LEDs full on and full off. If you want to generate more than 7 colors, you can do so by varying the brightness of the individual LEDs between full on and full off. The analog write function let us do this. This function lets you dim a LED from full off to full on over a 255 steps. So this is the code. Here two more functions we have written, that is show spectrum and show RGB. Show spectrum and show RGB. Show RGB displays a single color on the RGB LED. You call show RGB with the number of a color you want to display. Show spectrum steps through all the colors of the RGB LED, displaying a rainbow. Show spectrum actually calls show RGB. Show spectrum, this function steps through all the colors of the RGB LED. It does this by stepping a variable from 0 to 768, the total numbers of colors, that is, and repeatedly calling show RGB to display the individual colors. In this function we are using for loop to step a variable from one value to another and perform a set of instructions for each step. For loops are very handy way to get numbers to count up and down. Define an integer variable called x. Now we will use a for loop to make x count from 0 to 767. That is because for a for loop we will repeat the next statement, which in this case is everything within the following brackets. Show RGB, this function translates a number between 0 and 767 into a specific color on the RGB LED. If you have this number, count through the whole range 0 to 767. The LED will smoothly change color through the entire spectrum. Base numbers are 0 for pure red, 255 for pure green, and 511 for pure blue, and 767 for pure red. Again, number between the above colors will create brains. For example, 640 is midway between 512 pure blue and 767 pure red. It will give you a 50 by 50 mix of the blue and red color, that is resulting a purple color. If you count up from 0 to 767 and pass that number to this function, the LED will smoothly fade between all the colors because it starts and ends on pure red. you can start over at 0 without any break in the spectrum. Here we will use an if and else statement to determine which of the three, that is red, green, blue, each of the cases span 255 because analog write wants a number from 0 to 255. In each of these cases, we will calculate the brightness for each of the red, green and blue LEDs within the RGB LED. For case 1, that is red goes from on to off, that is red intensity 255 minus colors, and green intensity is equal to color, that is green goes from off to on, and blue intensity, that is equal to 0, blue is always off. So this is for case 1. Similarly, this is for case 2, color less than equal to 511. In this case, red is always off. And similarly, case 3, here color is greater than equal to 512 and green is always off. Done uploading. Now switch on the circuit. So we can generate from this code both the functions. So finally we can add both the functions, the individual RGB LEDs on and off, and the different brightness of the individual LEDs between full on and full off. So this is the total function or code. Here on and off individual RGB LED, and here case 1 and case 2 and case 3. From here different brightness of the individual LEDs between full on and full off. Now upload this code on our Arduino board.